So, hello everyone, and welcome to this Ask AuxEn Anything live stream that we are going to conduct every weekend on Saturday. And this will be an online platform which will aim to just answer your queries. Those queries may be uh, related to your projects, or those queries may be related to some issues that you are facing with RCC or steel design, or any construction or site issues. So we'll be meeting every weekend at 7:30 p.m. Indian Standard Time, and we will take your queries and try to answer them to best of whatever is our ability. So I'll directly start with answering the queries which we have received over the Google form. I'll begin by taking them, and then there are some queries in the YouTube uh, comments also. So I'll take them as well. So let's begin without saying much. So first, so continuing from the last week where we had stopped, I'll be continuing from those questions that we had received after completion of last session. Okay. So first question is by, and there are a couple of, I think 4 or 5 questions by Engineer Tosh Agrawal. He is from Raipur. He is a working professional, and he has a few queries that he has asked. So I'll be beginning by taking his queries. So he had mailed those queries to me. I'll just start by answering them. Okay. So what I'll do is I'll need to stop my screen sharing. This session will involve some fiddling between different screens and different tabs, so you will have to bear with me for that. Yeah. So Mr. Tosh, first question he was asking, how roof leg is connected to built up column for crane. Second question he asked was, do we need bracing for roof leg in minor direction? Third, he asked, do we need to model lacing and batten in STAD model? Okay, and he has given us one image also, so I'll share that image as well. So let me just take a screenshot. Yeah, I guess everyone is able to see this image. So his first question is, how roof leg is connected to built up column for crane. So see what happens when we make sheds which involve cranes. Usually this portion of the column will require a larger size because it has to support your crane. What do I call it? Gantry girder. So usually it will require a larger moment, a larger sectional area. Sorry, it will require larger movement capacity. Therefore, it will require a larger sectional area. So there is a possibility that this column is of a larger cross sectional area. Maybe we make it using built up members. So I'm connecting, let's say, by using two channels front to front, or I may use two I beams in whatever configuration required, or whatever. I may even make columns out of four angles, whatever suits me. I can do that. So usually this will be my column. Here, let's say, is my uh, gantry girder. On this, my crane bracket or my crane will be supported. And then to support the roofing system, now I don't require such a heavy cross section size of my column, which was required for the crane support. So now I will provide a smaller cross section. This is called as the roof leg. So now question by Mr. Tosh is, how roof leg is connected to built up column for crane. So this is a generalized question I had told him also. So it will depend on how you are. First of all, what is your section that you are using for your column below, and then it will depend on what is your roof leg cross section that you are using. One of the ways is, I had told this in last Ask AuxEn Anything session also. So one of the ways is that you will have a top plate on the top of this let's call it as the main column. So on the top of this main column, you will have one plate. Okay, this plate will then be connected to another plate which will be joined to the bottom of this roof leg. So let's have this blue plate. This blue plate is joined, let's say, by welding to this roof leg, and then this orange plate is provided on the top of this main column, and then I can have a bolting arrangement made over here. This is one of the options. Of course, there will be stiffeners, etc., to stabilize this connection. This can be one of the possible options. In this image, what they seem to have done is that they have taken the roof leg below, so they have sort of continued the roof leg below, and then they have provided some arrangement over here. All right, so roof leg is going inside. Let's say this black color was the roof leg going inside, and then they have provided some arrangement, maybe by some plates or whatever. So there can be multiple options of connecting this roof leg with the main column frame. It is difficult to pinpoint a possible single alternate for it. Okay, there will be multiple options that you can think of. It will depend on the type of section that you are using for the roof leg, type of section that you are using for the main column. All right. Moving on to second question, do we need bracing for roof leg in the minor direction as it is weak in that direction? Of course, you will need to follow all the uh, s- principles that will ensure that you have a stable and a serviceable system. So if bracing is needed to stabilize the roof leg in minor direction, of course you will need to give that. Nothing changes. So if it's a roof leg, the structural steel concepts won't change. All right. Third question is, do we need to model lacing and batten in stat model to get actual force? So this is a query which many of the practicing engineers have. What happens is that when we make any built-up column, steel built-up column, whether we make it in STAD or whether we make it in ETABS, usually we make it only like this. All right. We will not usually model the connecting elements which makes it as built up. It can be batten plates or it can be lacings. So we don't model it. Why don't we model it? Because in the elevation, if you see these batten plates, we will assume that they are not adding to the member strength of this built up section. Why do we assume so? Because these lacing battens are not available at every cross section along the length. So if I were to draw this elevation and if I were to mark this, let's say battens, so battens are provided at certain spacings, isn't it? So now if I model a cross section which has plates also, essentially what I'm saying that I'm, let's say, making this section where I have a batten plate and I also have the column cross-sectional members. But suppose I were to take a section over here, naturally at this location there is no batten plate. So here the cross-section should look like this. So now when I am checking the member strength in STAD or ETABS, usually we will not be modeling any of the battens or lacings because the battens and lacings are not throughout provided along the length of the member. That means they are provided at certain spacings. If I had a situation where I had a continuous plate like this all throughout the length, okay, understand? If I had provided a plate which was provided all throughout the length of this column, then I would have included it in my cross section when making model in STAD or ETABS, not otherwise. So whenever I'm making any built-up column or built-up beam or whatever, I will not include lacings and battens in that assembly. Okay. So then if I'm not including it in my assembly, the next question will arise that how will I get the actual force in them due to any of the actions? So if you want to find out the forces, the mechanics is simple. Let's say this was my I'm taking a case of baton. So if this was my force, I can find out this was my external force acting on my column, and this was my baton plate. These are my baton plates. So as per the external force, I can easily calculate the force that will be transferred in the baton by simple mechanics principles. Very easy in batons. I'll just take the entire external force and assume that it directly goes to this. Maybe I'll do a half and half. Okay, because there is a baton on the other face also. Or if there is a UDL type of a force, I can, of course, depending on the tributary uh, area, I can easily calculate how much force gets transferred to this baton. Okay, if I have a case of lacing, and let me just draw lacing. So if I have a case of lacing, then depending on the angle, I can easily find out the member forces. In this, we do one thing, that let's say there is a force over here. So I'll not, in my calculation, I will not assume that both these lacings are going to resist this force simultaneously or together. So what I will do is I will assume only one lacing is going to take this force. Okay. Now that force may be due to point load or due to UDL, whatever. So I'll be doing like this. This is in case if there is an actual load that is acting on the column or on whatever open web system you have created. If there is no actual load acting, let's say this was a case of column and it was subjected to pure axial force, so there is no actual load acting in this direction which will generate any forces in the baton or lacing. Then what do we do? Then the simple rule that we use is the 2.5% rule, where we will say that if no actual load is acting, then we will assume this to be a notional load, which will be equal to 2.5% of this P. And for that load, we will design this lacing or baton. So this is how we do it. So we will not model the lacing and baton in our analysis model, STAD or ETABS, and we will do the calculations for forces like this. Once you get the forces, then you will assume that this lacing is under compression, calculated accordingly, and over here you will assume that this baton will be taking moments and shears. There are formula given in the code which tells you how to calculate those moments and shears. Is it okay? Okay. So this was his question. Then his fourth question was, at topmost and at bottom of built up column, do we need end batten? Yes. Even if it is laced, even if it is laced, usually we will end it up with an end batten. So for example, this is my column and two built up columns, two channels together. In plan view, they are like this. And maybe I'm providing lacing. So wherever this lacing system ends, the usual practice is that we will end up by providing a end batten over here. Why so? Because this will also act as our stiffener for making this column to base plate connection. So yes, in the end, usually we do provide this end batten. Okay, all right. How is gantry girder supported on main column? Again, there can be multiple options. One of the options is the image that you have shown over here, where the gantry girder is resting on this column itself. Another option, if you don't have so much space available, is to take out a bracket from your column and then rest a gantry girder on it. That can be one of the other options. There are other options where you can hang, in fact, you can hang the gantry girder from top. The crane will be not running over the gantry girder, but it will also be hanging. Sorry, you can hang the gantry girder from the top, and then, in fact, there have been such projects where the crane bracket then hangs like this from the bottom flange of this gantry girder. Crane girder will hang from there, and then your crane will be operational. So uh, I mean, what I want to convey over here is that there cannot be a one line answer for this, how gantry girder is supported on main column. There can be several different options, several different configurations available. Continuing with Mr. Tosh and his questions. So he had another question over here. It was more of a practical question where he was asking that suppose in his case he has a stepped column, and now in this stepped column, I'll just, yeah, I don't know. The image is visible. This is the image. So his question was that suppose he has this case where he has a stepped column, and due to some reason maybe there is an offset on the outer face, and now he wants to fit a sheeting I mean fix a sheeting over here, but due to this offset, how he'll how will he manage? That means if I'm going to provide a girt over here, I may require a larger girt over here to sort of manage my connection with this column roof leg. Why? Because this roof leg was at an offset, and because of this offset, either I would require a longer or a bigger girt, but generally we don't do that. We will not provide longer girts or bigger section size girts, because generally we like to keep them as typical. So usually in these cases, what we do, that girt we will keep same, okay, but we will provide a additional cleat over here. Now that cleat connection can be made in different ways, but usually we will provide a cleat like this. It will go like this, and maybe then I can have my no, not like this. This is not a good way. Okay, so I can have my cleat like this, an additional cleat. I am just using a case of Z section over here, and then my Z section, is this Z? Yeah. Then my Z section, this is Z, okay. So then my Z section girt gets attached, and then my sheeting gets attached over here. Okay, so what I'm doing, by adjusting this cleat size, I can easily accommodate the differences in these offsets in the faces of column. Okay, so if some column is at a different offset than other, I can manage by not changing the girt size because it is difficult, but by adjusting these cleat sizes. Good. So this was question Mr. Tosh from Raipur had asked, and I think these were his questions. Very good. So let's move ahead then, and now let's open another set of questions asked by. Let me move on now. Yeah. Mr. Dipanshu Gupta is asking, no. Is there any course on design of tank ring wall foundation? No. We have done a course on liquid retaining structures, but not on. I mean, you cannot expect courses on such specific topics, isn't it? Right. Next set of questions. Mr. Shubham is asking. He is joining us from Nashik, and he is a working professional. He has asked some interesting questions. So let us try and answer his round of questions now very quickly. So, uh, okay, so Mr. Shubham is asking, I hope you can see this. His first question is, how can we perform? Oh, this is interesting. How can we perform design of retrofitting or rehabilitation of old structure or expansion of an existing structure? Is there any IS code for that? So, okay, this is not a small point for discussion. He's saying, how can you do the design for retrofitting or rehabilitation of an old structure or expansion of an existing structure? Suppose you had some structure which was G plus 1, and now the client wants to come up with G plus 2, and he or she comes to you and says that whether we can have an additional floor done. So that is the case of expansion. Or you go to some structure which is standing. Let's say there was an industrial structure, it was supporting a 5-ton crane. Now they want the same structure to be good enough to take a 15-ton crane. So you will require retrofitting maybe in that. Or suppose there is an old structure which is in a bad condition, and you want to increase its design life or performance, then you want to rehabilitate it. So in all such cases, how you can do so, I mean, don't expect me to be able to cover it in 5 6 minutes, but what I want to tell you, the basic concept would be that first step you should be taking some visual inspection, and you should be collecting visual information, visual data as much as possible. Okay, those visual data will help you to assess the condition and overall uh, structural integrity of your structure. Condition assessment, you can do it visually. Second step will always be to make a, now I am talking more with respect to design, in design offices, how you will take up that. So the second step will be to prepare what is called as an as built structural model. So as built will be whatever is on site, you try to prepare a model as it is as built. So suppose it's a steel structure that you are trying to do, it's easier because then you can see with your eyes what sections have been used, and it is easier to make an as-built structural model if it's a steel structure. If it's a RCC structure, things become more complicated. You may have drawings, you may not have drawings. If you have drawings, it's good. If you don't have drawings, then you will have to go for some sort of uh, investigations, which will enable you to sort of find out the reinforcement that is there. You can use a bar locator, or you can use some scanning equipments to find out the reinforcement placements, dias, everything. Same thing you will do for column, beam, and then substructure again will be a mystery. So you, if you don't have the drawings, if you don't have the information, maybe you will have to dig up and try to find out what size of footing is there. Basically, as built structural model is required. Then you will try and figure out how much, what is the new scheme that you want. So suppose if it was a case of expansion, maybe you will add another floor. Of it, or if it was a case of retrofitting, maybe you will add additional loads, whatever. So now you will make your new system overlaying on the as built. Okay. So that also you can do on the same structural model that you have created. Once you do that, once you run your analysis design, then you will understand that how much strengthening, how much retrofitting your as-built system needs, whether it needs or it is capable of taking on its own without strengthening, or it needs strengthening. That you will identify and understand. So then you will analyze and design, and then find out the required treatment needed for the as built arrangement, and then you can work out the new design for the new system that you're going to provide. In such a way you can come up with a scheme. Retrofitting schemes have to be thought with a viewpoint of ease of executing it on site, because otherwise it will not be possible if you come up with some systems which cannot be executed properly on site. So your retrofitting scheme has to be sort of in agreement with the possible fabrication or possible construction that can happen on site, and then you will prepare a scheme and drawings and design for it. I know this is not a very good answer because these things cannot be explained in a span of 5 6 minutes. But yeah, I guess some light I have been able to throw. Is there any IS code or any reference book? I have no. I mean, there must be book, but I have not. I am not in knowledge of a book which deals all out with the retrofitting of structures only. Generally, retrofitting is added as a additional topic or additional chapter in books. So at least I am not aware, but there must be books. If someone in the audience is aware, or someone can comment on the YouTube video, they may please do it. And then schemes can be different. As I told you, in old structures, you may be, you can do jacketing. You may, these days uh, there is a way of doing strengthening by carbon wrapping. But of course, it will all depend on under which action your members are failing. So, for example, if your member is failing in compression, carbon wrapping may not help it. If your member is failing in shear or flexure, carbon wrapping may provide some supporting, some retrofitting possibilities there with carbon wrapping. If your member is failing in flexure or shear, for compressions, if it is failing in axial compression, maybe carbon wrapping is not a good solution. Maybe you will need to go with jacketing, or you will need to integrate some steel sections with it. So it will all depend on what type of forces, what type of structural failure is being observed. Depending on it, the retrofitting scheme will have to be developed. So we had done one project where there was a existing cement plant. There were different buildings of those cement plants, and it had a certain capacity. So it was that cement plant and its structures were constructed for some. I don't remember the figures, but for some capacity, some it was a small cement plant. So I think 1,000 tons per day or something like that capacity cement plant, and then they wanted it to enhance it to some 1,500 tons per day capacity. So because they wanted to enhance the capacity using the same structure, they wanted to do retrofitting for it. And also there was a seismic upgradation of that location. So earlier the zone factors, when they had done some 30-40 years ago, were different, and now the zone factors had changed. So we had to do what is called as a seismic upgradation also, and we had to do a capacity upgradation also. So yes, there are often these types of projects that you may get as a structural engineer. uh, so yes, retrofitting, restoration, rehabilitation, strengthening is an interesting area. Right now, can you take up some course on the same? I don't know. Not thought about it as of now. His next question, Mr. Shobham is asking, how can we design anchor bolt? Yeah, this is a question which many of engineers have been asking me about the anchor bolt and its behavior, and how to find out the cone failure, because I am also not very good in about this aspect as of now. So about the anchor bolts, especially when anchor bolts are used in existing concrete, how to do that, I'm not very aware of those codal provisions or methods, especially the cone failure. So pull out I'm able to do, because pull out is known. IS 456 gives you the pull out calculations. But cone failure calculations, as of now, I'm not aware. But many engineers have asked this, because this is an issue which is faced by practicing engineers. We also face this, but what we do is, if we are using some anchor bolts, we usually approach some company which is uh, providing these anchor bolts, like Hilti or like Fisher, or other companies which provide these anchorage systems. So we tell them to do these checks for us, and then they usually submit some calculations. So right now it's a gray area for me. I'm not aware of these things, but yes, I will plan. I'll study them, read more about it. Maybe in one of the upcoming sessions we can discuss in more detail. But right now, beyond the normal pull out calculations, I don't have enough knowledge about the cone failure calculations. Okay, so very good. I will just take up next question. So Shubham's question we have answered. Now let me just quickly go to, I don't know what is the next question. Farhan. So Farhan is from Aligarh. He start asking how to start a career in structural engineering. This. I'll skip this question. Maybe Mr. Farhan, you will find enough information on the internet for this. You can connect with people on LinkedIn or other professional networks. They will help you out. I'll move on to next question. So Mr. Saif Ahmed, Mohammad Saif Ahmed from Guwahati, he's a working professional. He's asking, can you please throw some light on transfer girder and floating columns as per IS code? Can you please tell roughly how to design in detail? So see, structural concepts will not change. Structural concepts will remain the same. What will change will be the design actions that you need to be more careful about. So maybe if you are doing a transfer girder and there is a floating column on it, maybe the issue of long term deflection is very critical. Of course, bending and shear you will be able to design, but the issue of deflection, especially the long term deflection, becomes critical. Okay, the issue of construction stage analysis becomes critical because as the floor by floor is constructed, especially this transfer girder will face a distribution of bending moments that will be different from the final bending moment that you will get when entire assembly gets constructed. So you should be aware of the construction stage analysis and you should try to do this kind of an analysis. Typically a software like ETABS will do it for you. You should be very careful about the long term deflection. Why so? Because with any changes in the deflection over a period of time, the behavior of this floating column or the movements in this floating column will also undergo variation. So you have to be careful about it. Other than that, if there is always this question that can this joint be a pin joint. So as long as this assembly is a RCC planted column and a RCC transfer girder, I'm not sure how in detailing uh, a pin joint can be created. Although you might have seen, I don't know, I have seen such details, whatever they do, that they will bend the bars like this. Although I'm not sure if it can work as a pin joint, to what extent this can work as a pin joint. So about this, I have my opinion reserved whether this can act as a pin joint. If it's a RCC system, if it's a seal system, of course I can create a beautiful looking pin joint over here and I can proceed with the transfer girder design. But whatever you do about the end conditions for this floating column and transfer girder, I think the important design actions that you should remember is the long term deflection and the changes in the bending moment and shear force due to the consumption stage. Okay, so I think you need to pay more attention to these issues. Other than that, I don't think the design will be any different from a regular design that you would do. Of course, if it falls under the deep beam classification, suppose, then you should check that as well. But nothing special or different that you need to do other than those two aspects that I mentioned. Okay, very good. Mr. Aftab is joining from Bengaluru. He is a I thought he was a working professional, but he has written over here undergraduate, postgraduate student. He has an interesting question. So what I will do is I'll just paste it. Sorry. His question is interesting. Let me just very quickly take it. Nice. So what do I do? Okay, yeah. Wait a minute. I'm just okay. Good. So Aftab from Bangalore, he is asking, and this is a query which is the query of many of us. So let's see what he's asking. How to design a beam when considering envelope or when reversal of moment is present. Okay, so he's asking, let's say he had a bending moment diagram and he was, let's say he's checking it in envelope. So for some load combinations, he is getting a hogging moment. Okay, let me just put some figures over here. I'll assign a negative value for hogging, let's say. So 140 kilonewton meter was hogging. And at the same section, the Sagging moment is, let's say, at the face of the beam, maybe due to some load combination involving seismic, there is a sagging moment of 180 kilonewton meter. Okay, this is the sagging, and my beam size is, let's say, 300 by 600. So the mu limiting for this is around 220 kilonewton meter maybe. Okay, now this is the situation. Are you clear what I'm telling? So this was his question. If in a section both hogging and sagging movement are present, and I'll just take a case where none of them is exceeding the mu limiting, then what to do? Then things are simple. So for 140, whatever steel you will require, because it was a hogging movement, that means tension was on the top face. So I will provide a beam reinforcement at the top face. Do you get it? So this will be the steel for the 140 kilonewton meter moment. Similarly, for 180, whatever steel was required, because it was sagging, I'll provide this steel for 180. Now things were simple because uh, both were the cases where my mu limiting, I mean, my moments were lesser than mu limiting, so they were a case of singly reinforced section. Now the thing will become interesting, and that was what his point was. That let us say now that in this case, I get a situation where this moment is 260 kilonewton meter, okay, and this moment is 140 kilonewton meter. So now what is happening for this 260? Tell me what will happen. Will I require only top steel or bottom steel or both or none? What will happen if this 260 kilonewton meter movement was hogging movement at the other end? For this movement, will I require only top steel, only bottom steel? What will happen? So if I choose to go ahead and detail it as a doubly reinforced cross section, now I will require AST for 260, plus I will also require some ASC compression steel for the same 260. Are you with me so far? Hello. I hope you get it. So this time you will require the compression steel also for the bending moment of 260 kilonewton meter. And then for the other load combinations in the envelope, maybe you need to have this steel as well. So you needed some AST for 140 kilonewton meter bending moment also for some other load combination. So now the question is, how do I do this? How do I manage? Suppose this AST for 260 was 4 bars of 16 which I provided. This ASC for the same 260 was, I'm just taking some hypothetical numbers. This was some 2 bars of 16. Okay. This was to maintain the doubly reinforced cross section for 260 kilonewton meter movement. Now for this 140 kilonewton meter sagging movement at the face, let us say I require 3 bars of 16. So should I add this 3 and 2 and provide 5 bars at bottom, or should I provide the higher of these two? What do you think I should do? Hello. My question is, if you have understood what I'm trying to say over here, so I required 2 bars of 16 dia as a compression reinforcement for the movement 260 kilonewton meter because it was exceeding the mu limiting. But for the other movement 140 kilonewton meter, which is for some other load combination, sagging movement, I require some 3 bars of 16. Now both these bars are the bar requirements at bottom. Question is, should I provide 3 plus 2, 5 bars of 16, or should I provide 2, or should I provide 3? So the answer to this will be, I'll provide the higher of these two. So I'll maintain 3 bars over here. When I maintain 3 bars, what will happen when the load combination is this, which leads to 260 kilonewton meter bending moment at the face? It will have the 416 at the top, and it will have it requires 216 at the bottom, but we have provided 3, so this section will be good enough. And when the moment is 140 kilonewton meter, I already have 3 bars, so it will also be taken care. All right. So in such cases, if the situation is this, that for an envelope case, for one of the moment, your cross section is becoming doubly enforced. In this manner, you have to provide your detailing. Okay. All beams are not doubly enforced, and if compression steel is provided due to reversal, okay, I think we have answered. Okay, so I hope his question got answered. Very good. So this is quite often we face this challenge, and yeah, I must add one thing over here, that in such a case, if you have provided this bar, compression bar has been provided over here because it was a case of doubly enforced, then you have to be careful about the curtailment length. You don't, I mean, decide the curtailment length accordingly, depending on the bending moment diagram and its requirement. Also, be very careful about the development length that you need to provide at the ends, or anchorage length that you need to provide at the ends. Be careful about those things. Okay, nice. So I'll move ahead quickly. Next question we have is from Mr. Shoaib. Give insights. What is he saying? Give insights on the design of connection for inverted V brace. Uh, I am designing bracings for the first time, so please. I am designing the bracings for the first time, so please, basics like where to connect. Okay, I don't think this topic can be covered in a matter of 5 6 minutes. Uh, but I can provide you references. First of all, what is the inverted V brace? So I assume that he is asking it for a steel building. So in steel building, if I have a steel uh, column and steel beam and inverted V brace may look something like this. Okay, and then here I have to connect it to the beam and to the column. Now the answer is not cannot be completed in 5 6 minutes. Insights on connections, there are different options possible. First of all, you may have an eccentric V brace, you may have a concentric V brace. Here this connection, you may you may detail and design it as a pinned connection or a rigid connection. This connection over here, you may connect it to column or to the beam. So there are a lot of different possibilities. If you are studying these issues for the first time, I would suggest you to go through some documents. You can go through IS 18168, which is which is a new code for ductile design and detailing of steel structures. Additionally, you can have a look at AISC 341, which is the same American code for ductile design and detailing of steel structures. Why I'm referring you to these codes? Because they in depth cover the different types of bracing systems and their connections also. Additionally, you can also have a look at AISC 358, which is, I think, if I remember correctly, a code for pre-qualified connections. Can someone just correct me if I'm wrong? AISC 358. Let me just check. AIC 358. Is it a code for pre-qualified connections? I'm just checking it in the background, the number at least. So you can have a look at that. Yeah, pre-qualified connections. But I think that will not help you a lot. AIC 341, you study AIC 341, and of course you can refer to the parent steel code AIC 360. Okay. So you have a look at these codes. This topic is quite vast, and if you are reading it for the first time, it cannot be answered within a span of 5 to 6 minutes. Okay, very good. So let us quickly move ahead. Very interesting question by Mr. Jaisal. He is joining us from Calicut. He is a working professional. How to analyze beam with an opening? And the same question was, I think, also posted by uh, Mr. Sandeep, who had joined, who had put this question. No, not Sandeep. Who had put this question? Mr. Jaisal had put it on the YouTube comment also and also on the Google form, but there was one more person who had put it. Yeah, Mr. Pritesh Jain, who was joining from Pune, he had also put this question. Please, please highlight or please throw some light on sleeves or openings and their locations in beams. Yeah, so beams with openings is a complex issue. Uh, it's again a vast topic, but what I will do is for small openings, that means the openings that you might encounter in your day-to-day projects, which may be some openings required for taking some electrical lines or some sleeves, okay, which will typically be not more than, let's say, 3 to 4 inches or 75 to 100 sleeves, at max 150 sleeve if you want to cut. Let's talk more about it right now. First of all, what will be the ideal location where you would like to cut your sleeve? Let's say this is a beam with a span. Where would you ideally like to provide your sleeve location? Ideally speaking, I mean, if you were given a choice, uh, yes, please tell me. Where would you like to give? So the basic principle would be wherever taking out concrete does not affect its structural integrity and structural strength. Okay, that remains the basic principle. So if my bending moment diagram in a beam was like this, hogging, sagging, hogging maybe. So hogging means compression is at the bottom in the hogging zone. Sagging means compression is at the top in the hogging zone. So I do have the slab also over here. This is my slab thickness also. So typically if I want to remove some sleeve from here, I would like to do it in some zone which is near the point of contraflexure, okay, which is near the point of contraflexure, and maybe over there somewhere at the, just a minute, where is the eraser? Somewhere near the, and assuming that neutral axis was somewhere over here, okay. So I would typically like to have somewhere near the pointer of contraflexure, let's say L by 3 to L by 4. And maybe over here I would like to cut somewhere near the neutral axis maybe. Why near the neutral axis? Because below it I will be having my tension steel. Above the neutral axis my concrete is in compression. So below the neutral axis, not on the neutral axis, slightly below the neutral axis, of course I have to have a gap for cover also, maybe 25 So slightly below the neutral axis I can position my sleeve, okay. This I am talking about small openings, small sleeves, uh, 75 to 100 Of course, I will be mindful not to cut the tension steel. Therefore, I said below the neutral axis, but around 50 to 60 above the bottom face, because I have to be mindful of the cover and the tension steel as well. So if from this zone I am removing concrete, concrete was not required over here, so I am in a happy state. It's okay to remove this piece of concrete from here. Okay. Now, uh, if I do this, and if this sleeve was planned after the beam has been constructed, I cannot do much when it comes to strengthening this. Maybe I can fit in a GI pipe inside. Okay, so I can fix a GI pipe. Why GI pipe? Because it will add to some strength of this weak zone that I have created. Maybe I can do that. Most of the people don't do it. If this sleeve is planned, that means there is a planning that a sleeve needs to be provided. Then what I usually do is that I will first of all position my sleeve. I will put closely spaced stirrups, and if the sleeve size is slightly larger, I can have a diagonal reinforcement also added to avoid the diagonal cracks that originate at these locations. So I can have closely spaced stirrups. In this case also, I can fix up a GI pipe which will act as a stable, strong core around the sleeve, and I can in fact weld my stirrups to this. Okay, and if required, some sidebars also, and then I can do the casting. So this will behave as a very good stable system. This is what I can do in cases of small sleeves, small openings. But if the opening becomes larger, and if it is going to eat into the cross sectional area of your concrete, then it has to be properly analyzed. Okay, then it has to be properly analyzed. So in such cases, you should ideally prepare a shell model of your beam. What I will suggest, so you prepare a 2D shell model where you will represent your beam as a shell element. So you make your beam out of shell elements like this. You make the actual depth, model the actual depth over here, and the thickness of this shell you provide equal to the beam width. So basically, if you are, let's say, preparing this model in any software, you assign the shell thickness equal to the beam depth and the actual beam width, and the actual beam depth and length you model. And then you remove these elements which are going to represent the opening. So you remove those elements, and then you apply the loads, check the stress levels over here, and compare it with the bending stresses and shear stresses over there. Okay, is it clear? So when these questions were asked, I also came across an entire book which has been written on this topic of openings in concrete beams only. So there is an entire book written, and if you're interested, you can download this book. It's easily available on the internet. I'll just share that book on the screen. So I was quite fascinated that there was an entire book on this topic. Uh, so I'll just share my screen. I don't know if you're able to see it. So you can note down the name of the author and you can download this book. So an entire book on concrete beams with openings. Can you see this? Quite fascinating. Yeah. So beams with small openings, beams with large rectangular openings, now torsion in beams with rectangular openings, effect of pre-stressing. Quite fascinating book. So you can go through it. Okay. So all of you who have these issues related to openings in the beam can go through this book. Quite informative book, and I will recommend that you may go through it. Okay, very interesting. Uh, Nusrat Fahmeen is saying, if the GI pipe is welded to stirrup, will it not corrode due to exposure to environment? Uh, No, I mean it is galvanized, so I don't think it should corrode. But if corrosion is an issue, maybe you can come up with a stainless steel pipe. Okay, you can come up with a stainless steel pipe. Although if I'm using a galvanized pipe, maybe corrosion will not be an issue. But if you are in such an environment where corrosion is a problem, you can come up with the stainless steel. But then be careful about the uh, welding it with stirrups. So the welding weld should be compatible between the stainless steel pipe and the stirrup. So a compatible weld has to be used there. Okay, very nice. So beams with openings, I think we have. So that book is highly recommended. Okay, just download that book. It is freely available on the internet. Take it from there. Mr. Balaji, just a minute. Mr. Balaji is joining us from Margoa. He is a working professional. He is asking, "Hi, can you please explain the moment coefficients for tanks?" So my first question was, why are you referring to these moment coefficients? The day and age of moment coefficients is long gone. I mean, you should have referred moment coefficients when you did not have enough. Uh, what should I call? When you did not have enough computing power uh, to do the computations for these types of liquid retaining structures. But now you have enough computing power when it comes to uh, the FES softwares that you have in the form of STAD, ETABS, etc. So I don't really understand why you want to use these obsolete moment coefficients. And the moment coefficient figure also that you shared was from 1967 code. So it has long been superseded by 2009 code and now by the 2021 code. So even if you want to use moment coefficients, you should not be using the 1967 version. You can now use the 2021 version for moment coefficients. But because you have asked, I'll just quickly tell you how you can read those. However, I will not recommend you to use them uh, because we have better tools available. Okay. So you don't use log tables these days because you have calculators available, right? You will not be relying on log tables. Similarly, no point in using those tables anymore when you have good computing methods available. However, because you have asked, you need to refer to these tables now. 2021 IS 3370 Part 4 Section 2. Section 2 is for tanks, and I also have opened the Section 1. Section 1 is for wall panels, plates. They are calling it as plates. So for rectangular tanks, you can refer to these tables. These tables essentially give you the moment coefficients. So I'll just show you how it is done. So these are the different types of tanks given cases. So you first pick up what is your case. Usually it will be either free or hinge or fix at top and fix at base also. It's very rare to see a hinge based tank. Nobody provides it except in the books. You will not see hinged base tanks provided anywhere. Okay. It is quite difficult to construct and ensure waterproof tanks with hinged openings. So no one does it. But the books do for some reason which I don't know. So anyway, so first of all, you decide which situation matches with your case. All right. Then you need to go to these table numbers. So for example, our case matched with the case 3, let's say. Okay, our case was a free top, so our there was no slab at top and we had a fixed base, so our case matches with case 3. Now when I have to look for moment coefficients, I will go to these table number 74 to 103. All right. So depending on the B by A, where B and C are the plant dimensions, A is the height. So depending on B by A and A by B, I will need to now go to these tables. For example, just to show you the example, I'll just show you one of them. So let me go to table 74 maybe. Okay. Table 74. Just a minute. I don't know what I'm seeing. Table 86 maybe. Okay. Table 86, we go to this. So your tank will have a long wall, it will have a short wall. So for example, this table 79 is for the short wall, and this table is for B by A of 4, C by A of 1.5, and then you will see moments MXC, no, MZC, MYZC, MYC. Okay. So MZC and MYC are the moments of our interest. It has been explained that for a particular moment direction, or for a particular moment notation, the enforcement direction has to be placed along which direction has been explained in the code before. You go to that, refer to that explanation first. These are the moment coefficients. It will be multiplied by some other values like the triangular pressure intensity, the height, and etc etc, and then you find out the moments, and these are at different heights from the bottom till the top. So in this manner you have to find out these moment values from the coefficients given. Okay. Now what about shear? So these tables in the part 2 of IS 3370 does not cover shear. So for shear, it refers you back to the IS 3370 part 1. So whatever your condition was, you need to go back to IS 3370 part 1 and refer that part for finding out the shear coefficients. So moment coefficients for tank walls, you will find it from here. Shear coefficients, you will go back to part 1 and get it from there. All said and done, I will not recommend you to use these tables anymore now, because I mean it just does not make any sense. When you have the tools available, use them, not these tables. Okay. I hope that makes sense. Just a minute. I just wanted to show you that line where they're writing. I don't know what is that. Where they're writing that the shear coefficients have to be taken from. Such a long table of. Yeah. So if you read 3.1.1, the shear coefficients uh, given in IS 3370 part 4 section 1 shall be used for the design of rectangular tanks, and then go to 3.1.3 for movements they have explained. Then you have a look at these notations. What is the meaning of MZC, MYC, MXC, etc. And then accordingly you find out the direction of movement and the reinforcement from there. Very nice. But don't use it. Don't use these tables. Yeah. So very good. Then we come to another question by Mr. Swastik Pujari. He is joining us from Mumbai. He is asking, I think he has questions, so I'll paste them over here and share my screen. I don't know. Let me share my screen quickly. Yes, so he's saying when we have a retaining wall for a basement, how to check for footing of retaining wall for maximum and minimum pressures. as we have prop at top and a stitch raft for basement. I'm not sure what stitch raft means. When we have a retaining wall for basement, how to check for footing of retaining wall? I don't know. I mean, the principle remains the same. When you have a retaining wall, this is your basement slab. So whatever is the pressure, I mean, from the forces, whatever triangular forces, etc., you have applied, it will lead to some pressure or some overturning movement for which you have to ensure pressure is satisfied. So the process of checking pressures remain the same. I don't understand it how it will be different from any other case that we come across. So I'm not very sure what he's trying to ask. Do we require to design stitch raft? I have also not understood what is the meaning of stitch raft. If stitch raft is a specific term, I'm not aware of. So if anyone in the live audience knows about stitch raft, they may please comment. I am not sure about this term, what stitch raft means. Do we require to design stitch raft provided between column footing for earthquake when we model it in safe? I don't know. In staircase, when we consider rest and support conditions, for example, landing slab is supporting the flight portion, then transfer of the load from flight to landing slab is required, then what would be the effective length taken for load transfer? And in general practice, still we continue the flight reinforcement through the landing to supporting beam. If you could please explain this third point with example of some sketch, it will be easier for me to understand. I'm not able to fully understand this question. So please, if you could provide some sketches with it. When fourth question, when we take stiffness of slab in ETABS for lateral forces to control deflection and time period. So we have to design slab in safe to encounter the effects on slab. Okay, so basically you are asking about the diaphragm effect of slab, I guess. Okay. So diaphragm, designing slab as diaphragm means when we design or when we have to design our slab for in plane lateral forces, because we were taking the stiffness of that slab in our time period calculation also, and because it will be through the slabs that lateral loads are transferred, so we have to accordingly design this slab for taking the lateral forces. So when we do this kind of a thing, these regions are called as the collectors. These zones will be called as collectors, and these regions are called as the chords. So imagine this slab to be acting as a deep beam. I'll just draw the plan for this. So if this was my slab in plan view, this was some Lx and this was some Ly maybe, and my earthquake force is, let's say, acting like this. So imagine that this slab is nothing but a beam, deep beam of depth Lx, because my earthquake force is acting like this. Okay. So what will happen that these elements will act as compression tension elements, because this becomes somewhere my neutral axis. So these are my top fiber, bottom fiber, something like this. So these elements I call as my chords. So these will have tension and compression depending on the direction of earthquake forces, and the majority of shear transfer. Of course, it depends on the position of vertical members, but shear transfers in plane shear transfer will take place near these zones. Just like imagine a case if this was a beam, so shear transfers would take place over here. So these zones will be called as collectors because they are collecting the forces from slab and transferring it to the vertical elements. So when you are designing a slab for lateral forces, that is his question, you need to be careful about these issues, and accordingly you need to design these zones so that the lateral load transfer from slab to vertical element takes place effectively and safely. A good way to do this can be that you can construct strips over here. So design strip is a good technique that is available in ETABS and safe. So you can construct design strips For the effective width of design strip, usually you can take a 45-degree angle of dispersion, okay, from the face of this and at the half point. So you construct a 45-degree angle, and accordingly you will get this width of the design strip, which you can assume it to be effective as a collector element. Once you have that design strip made in ETABS or SAFE, then you will be able to integrate those forces. I mean, your software will do the integration of forces on its own, and then you can use those forces for design. So uh, you need to be more careful about these zones, the chords and collectors, when it comes to design of slab for lateral forces. So usually we call it as the design for diaphragm or diaphragm action. A very good document for this you can find on the internet. It is a document published by NEHRP. I'll just share with you on screen, and you can freely no download it on from the internet. I'm not able to get it right now. You just search for design of diaphragms, NEHRP document for design of diaphragms. Okay, just search it. You will be able to get it. Although, yeah, I got it over here. I'll just share my screen and show you. You can download it easily from the internet. It's freely available. So let me just show you quickly. Yeah, can you see this? NEHRP seismic design of cast in place concrete diaphragms, cords, and collectors. Although it is only for seismic forces, but remember any type of lateral force, if it has to be transferred to vertical elements, you need to take care of the design of cords and collectors. So, although the title would suggest that it is only for earthquake forces, but no, it is for all types of lateral forces. You need to take this in account. Okay, why don't we usually do it in Indian practice? Because in the Indian practice, we have usually thick slabs of RCC, so not like the Western America. I mean, by Western America, I mean not like the America and Canada and those Western European countries where they do a lot of timber construction, where their diaphragms or slabs are not very stiff in plane. Contrary to that, we have quite stiff slabs that we provide. So we are usually not very worried about this diaphragm issue. Okay. Usually a 150 thick slab with two layers of reinforcement at top and bottom. Our code says it is good enough to take all sorts of lateral loads and safely transfer it to the vertical element. Just in the chord and collector region, you have to be a little bit more careful. Otherwise, you don't have to think much about the diaphragm design. Okay, nice. Mr. Pritesh Jain, moving on to next question. He is joining from Pune. He is saying, please throw some light on sleeves. In beams, we have already covered. In shear walls, although this issue is not covered anywhere, but again, the principles would remain the same. Depending on the size of opening you need, you can provide uh, you can provide them. And if the opening is small, maybe you don't have to be very worried. If the opening is large, maybe you need to be more careful. When it comes to shear wall, there is a clause given in 16700, clause number 8.5.2. You can read that clause 8.5.2 in IS 16700, and basically it says that when the openings are, I'm reading it from the code, when the opening size is less than 800 or one third the length of wall uh, in height or length, the influence of opening may not be taken into account in the overall stiffness of the building. But if your opening exceeds this size, then you have to model that opening in your wall, and then you need to study the effect of that opening. Okay. And of course, you need to strengthen the sides of the opening with additional reinforcement. So for shear walls and opening in shear walls, you could refer to clause 8.5.2 of IS 16700 2023. Okay. Okay, very good. So quickly moving on. Very interesting. His next question is in raft or combined footing for boundary edge column, how to check one way shear. Acha, okay. So let me just copy this. What he's saying is this is a doubt which we quite often face. So I'll just share my screen and wait a minute. Uh, I will go over here. Yeah. So if you see his second question, Mr. Pritesh, is saying for boundary or edge columns, how to check one-way shear when the offset of footing. Okay, so it's a general question. What he's saying is, I'll just take as a general question. Suppose this was your footing, okay, and suppose this offset was 900 mm all around, but you had provided a very deep footing depth. Let us say your capital D was 1500 mm. That's what he's saying in the example. So what will happen now when I have to check my shear? I will check shear at D distance away. So when I go and check my shear at D distance away, what do I find? That my D distance away section lies outside the footing, isn't it? So what does it physically imply? Anyone can tell me? If my critical section for shear lying outside the footing, what does it physically imply? So basically, it physically implies that shear will not be critical in such a case because this region is already being protected in shear by the presence of this column. Okay, because most of the shear forces will directly travel to the column by the strut action, you could say. Okay, so the effect of shear is anyway not being felt in this d distance. Up till a d distance, my column is over there to take any kind of force, and it will be resisting all those shear forces as a matter of the strut action between footing and column. So column is sort of providing enhancement or strengthening to this zone till d distance. Therefore we check at a d distance away, okay, and then beyond. So if my cross section or if my section for critical shear is lying outside the footing, that means my entire footing, I need not check it for one-way shear. It is safe, and the presence of column will enhance its strength, and I need not be very worried about it. That is the physical meaning. Is that clear? Very nice. So this was his question. Now we come to questions that were asked to us by people on the YouTube comment section. So I will take those questions one by one very quickly. So Mr. Sandeep is asking how to decide when moment connection is to be given or design or shear connection. I guess he is asking in context of steel structures, when do we give moment connection, when do we give shear connection. Basically, that will depend on the choice of the structural engineer, and that will depend on the choice of the structural system that you adopt. The basic concept would be, I'll just tell you that if it was a case of, let's say, simple gravity load, first of all you also need to ensure lateral stability. You need to ensure stability in the vertical direction. But suppose I were thinking of this as a system which is to take lateral loads plus gravity loads both. Now in this system, it's a rigid portal. That means these connections are rigid. What will happen? This system can remain stable because it can develop moments for gravity loads also, and it can effectively counteract the lateral loads by developing end moments over here also. Okay, but suppose if this system was shear connected, will this system be stable for lateral loads? So for lateral loads, then there is no one, or suppose this was pin also. Okay. Now, can this system be stable for lateral loads? So now this system does not remain stable for lateral loads because I have provided a pin connection over here. So in such a case, then I need to add another system. Let's call it the bracing system, which will take the lateral loads in axial compression and tension. So what I mean to tell you over here is the choice whether to go for shear connection or moment connection or a rigid connection will depend on the choice of structural system, will depend on the uh, type of loads that you want to counteract and counterbalance. So all those things will be a deciding factor in choosing the type of connection. The type of connection will also depend on the type of members that you are using. Sometimes, if you are using hollow sections, maybe development of rigid connections may not be uh, very simple. So, in such cases, you may have to go for pin connections if you are going for hollow sections. So, it depends on a lot of things. It's difficult to it is difficult to pinpoint and present a single answer or to give a single answer for this question. Sometimes it also depends on the, let's say if it was a case of mostly this comes in situations when you are doing a PEV shed, let's say. Okay, so you were doing a shed. Now if I were to give a pin support over here, what will happen that moments will not be transferred to my substructure. If moments are not transferred to my substructure will be designed only for, let's say, the axial forces and for the moment due to the horizontal reaction over here. But still, I can design I can end up having a lighter substructure if this was a pinned condition. But if it was a fixed condition, a lot of end moments will be generated, and then my footing has to be designed for it. So suppose I was making my shed on a weak strata, maybe I could choose a pin connection over here. Okay, but then if I provide pin connections, lateral sway is a problem. So then I need to be careful about that also. So it's a decision that depends on lot of aspects, and it cannot be a one line answer. Okay. Okay, next he was asking when to carry out response spectrum analysis. You go to IS 1893 part 1 2016, and I think the clause 7.5 point something gives you the criteria when you need to go for response spectrum analysis. Basically, if there is any irregularity in the structure, that irregularity can be of geometry, or that irregularity can be of mass, or that irregularity can be of stiffness. If there is any sort of irregularity, usually we try and conduct response spectrum analysis for it. Okay, that is the underlying principle. But for more details, you go to IS 1893 part 1 2016. Okay. Mr. Sandeep is asking where to put staircase load when we are not modeling mid landing beam. Arre, why are you not modeling mid landing beam? Model it. Otherwise, you prepare a staircase model separately, and then maybe you just transfer those loads to columns. If you are providing columns in your main model, you can do such things. Okay, good. Mr. Pratyush Malviya is asking how to decide when to go for nonlinear analysis for RCC buildings. I'm not sure. I don't know. because I have never done any sort of non-linear analysis in any of my previous projects. So I don't know. TVZZ, he is asking how to design beam for envelope. I mean, this is a basic question. You just go and study first. I think in the earlier questions where we were answering Mr. Aftab's question, I think you might have got some idea about beam design in case of envelopes. Okay. Civil engineering software knowledge. He is asking continuous beam, which method is used for analysis? If you are using software, they are going to use the matrix method. I mean, all the computer analysis softwares will use that, irrespective of whatever system you have. So, yeah. Askar, Mr. Askar A, he is asking, please may I know how to calculate moment and shear capacity of steel section? Go to IS 800 2007. There are detailed clauses and provisions given which will help you for calculation of moment and shear capacity. What is the use of live load reduction factor? So basically, the concept of live load reduction factor is that suppose I were to design a substructure, okay. Now substructure, and suppose I had a case of multi-level building, okay. Now this building will have dead load and live load. Now when there is a live load, essentially it means that there is a probability that the live load may be there, may not be there. Now, when I'm designing this footing, for example, the chances that all the slabs are loaded with the 100% live load simultaneously at the same time is quite rare, isn't it? What I'm saying, the chance that all the slabs simultaneously at the same time are loaded to 100% of their live load intensity that we have assumed in design is quite rare. So if it is quite rare, the concept is then why should I design this footing for the full live load? Why not to design my footing only for a part of it? Or why not to design this vertical member only for part of that live load? See, for this horizontal element, we will design it for full live load because let's say during the design life, it is possible that at any instant the full live load may be present over there. Okay, so horizontal elements will design for full live loads, but I'm talking about vertical elements where the effects of live load are accumulated over the different floor levels. There we are raising this question that the chance that every slab level uh, which is within the tributary area of this column or vertical member is loaded to its full live load intensity, those chances are quite rare, and therefore I introduced this concept of live load reduction factor. So maybe for the ground slab I take only 80% of live load, here I take 70, here I take 60, whatever. So then these factors are given in IS 875 part 2, that when you are wanting to design these substructures or vertical elements, you could take a part of this live load for your design. So you can go to IS 875 part 2 for it, for an explanation on the live load reduction factor calculation. Okay, very good. Uh, what is okay? So I have explained why is every structure guy I know don't have beard and mustache. Oh, I don't know. I used to have beard. I don't have it now. But you seem to be having beard and mustache both, and I am sure you know yourself. So at least you know one structure guy who has mustache and beard, and that is you yourself. But I don't know why others don't have. Civil engineering software knowledge is asking column is y direction orientation. Which moment is considered? Question not understood. Uh, there were some comments. Probably the most. Thank you, Mr. Rahul. Uh, Yes, thank you, Mr. Tosh. Salik Trambu is asking, I have steel beam column with tapered section. I have seen PV supplier restrain the top and bottom flange. Yes. At Purlin Gut location with fly brace, can we also take LY as a restraint? Yes, you can. Usually, that is the strategy that they use. That, let's say, if this was my rafter, I'm showing in green color rafter, okay, and there was this purlin over here. So now purlin is getting connected to the top flange. So top flange I can assume restraint, but what about the bottom flange? It is unconnected. So what they do is, if I show this in cross section, uh, I will see my rafter like this, and I will see my purlin this time like this, Z purlin maybe. So what they will do, top flange is anyway connected directly because my purlin is resting on the top flange. But for the restraining the bottom flange, they will provide an additional brace like this. They usually call this as the flange brace. So this flange brace will take care of the bottom flange also. So in this manner, because of the presence of fly bracing at the bottom flange, and because of the presence of purlin at the top flange, I can assume this rafter to be effectively restrained against the lateral torsional buckling and for compression calculation in this direction, and therefore whatever is my purlin to purlin spacing, I can take my LX and LY for lateral torsional buckling calculations and for compression calculations equal to the purlin distance, purlin spacing. Is that clear? Yes, very good. Then Nusrat Fahmeen is saying, can we know why is the response reduction factor increased in higher seismic zones? Very good. I think you need to study some uh, basics about it. But the simple concept is that response reduction factor basically shows you what level of ductility you need to provide, and it also gives you an understanding of what level of forces you are going to resist. So the concept, if I were to explain, no, no, and you are wrong over here. Can we know why is the response reduction factor increased in high seismic zones? So response reduction factor actually does not change, does not increase with the increase in seismic zones. It increases with the type of structural system that we choose and the type of level of ductility that it can provide. Okay. So basically, the concept will go like this: that very in very very crude way, if I were to explain, if let us say 100 units of earthquake force are acting, and this is the way we usually explain in our courses also, because I find this easier to understand. So, if let's say 100 units of earthquake forces were acting, our concept, our underlying principle is not to design it as a uh, earthquake proof structures. Rather, we like to design it as earthquake resistant structures. That means we accept damages and we accept distresses in our structure. Only the thing is that it should not fall down. Okay. So what I do is, if 100 units of actual earthquake forces were acting, I will design my structure for only part of that force. So let us say I design only for 40 units of force. So I design my structure to withstand only 40. Remember, the actual force acting was 100. So now what happens to the remaining 60? So for the remaining 60, I will I will say that it will cause inelastic damages, because that is a very good way of energy dissipation. So I'll say that for 60, inelastic damages will occur. Okay. So I say that 100 units of force were acting, but I only designed it for 40. So basically, I reduced my response by a reduction factor of this. Do you understand? So in this way, for this system, I say that my response reduction factor becomes 100 upon 40. All right. So when I was using, and this gives me, let's say, a response reduction factor of 2.5. So basically, when I'm saying that I'm using a response reduction of 2.5, R factor of 2.5, I'm designing for 40, but I'm allowing inelastic damages corresponding to 60. Still, my structure should not fall down. Remember this. I take another case where I say that I am only going to design for 20. For 80, I am going to allow inelastic damages. So essentially, this means that the R factor becomes how much now? Going by the same crude logic that we are discussing, R factor becomes how much now? So I will say that in this case, R becomes 5. Okay. So you will notice that now I am only designing for a very small portion of actual earthquake, and I am relying on 80 units of force to be dissipated through inelastic damages in terms of cracking or spalling of concrete or other such load dissipation paths. So I am allowing 80 units to be dissipated through inelastic damages, but still I would not want my structure to fall down. That means this structure which has this R should require or should be provided with higher ductility, because it has to take higher inelastic forces and it has to dissipate them in damages, but still it should not fall down. So the level of ductility that will be needed will have to be higher in case of a system which has a response reduction factor of greater magnitude. Is that clear? So basically, when we go to higher seismic zones, we wish to have such systems which can give us higher ductility, because energy will be dissipated through inelastic damages, but still the structure should not fall down. So therefore, we would like to have such systems which can show us higher ductility. That means we will choose systems which will have higher response reduction factor, and because we now need to ensure higher ductility in these systems, we have to follow all sorts of design and detailing principles for ductile design. Okay, is it clear? So this is a very crude way of explanation. I hope you got some understanding for it. Nusrat is saying in seismic zone 3, SMRF is used. R factor for SMRF is more than this. Yeah, so I think you got the answer. So now in seismic zone 3, I am using SMRF R of 5. That means I am designing for even lower earthquake forces. But then how am I compensating it? I am compensating design for lower earthquake forces by providing a system which has much more ductility in terms of the rules that I adopt for special movement resisting frame. Because I have taken a higher R of 5, I am designing it for lower earthquake forces. I'll ensure that my system has much more level of ductility. Mr. Salik, I think he's answering to Nusrat. Yes, what he has written is right. I agree. Engineer's advice, he is asking, is it necessary to have 65% modal mass participation? Not the first three modes per se, but the first three modes which are contributing in the x direction or y direction. Okay, so numerically they may be, let's say, for example, mode 1 has mass participation of maybe 60% in x, mode 2 has 70% mass participation in y, mode 3 is a torsional mode 4 is having 10% mass participation in x, mode 5 is something else, mode 6 is having a mass participation of 8% in x. So when I want to add up, I will not add up mode 1, 2, 3 to check the mass participation. I will add up the respective modes where masses in x were participating. So I will add up the mass participation in mode 1 let's say the mode 5 and mode 8. Understood? So these will be the first three modes for X direction vibration. I'll add these up. If they account to 65%, then I'm okay. Otherwise, you can refer to table 5 of IS 1893 part 1 2016 to see what else needs to be done. Mr. Saif Chaudhary is asking if supports at the base are designed as pin supports for steel structure. For the sway, how can we control it? So if you want to control sway in systems where you are providing pin supports, one of the ways could be to provide additional bracing systems. You may have to add some bracing systems. Those bracings can be in plan or if possible in elevation. You will have to add such bracings, or maybe you will need to increase the stiffness of your rafters and columns or the beams and columns to reduce the sways. Are there other, as there will be other parameters which need also to be controlled? Yeah, so for sway, generally adding bracings, increasing the stiffness of beam columns is one of the ways. Acha, he has answered it. Yes, very good. Engineer's advice is asking the load transfer mechanism in basement is different than that of shear wall. Many structural engineer model, both in model, do we do they use any special stiffness modifier? I'm not sure what stiffness modifier they use. In code, it is given the modifier to be used for shear walls, although no modifier is given for the basement walls. But then you can decide if, if the basement wall is taking a lot of in-plane stresses, in-plane forces also, maybe you could give them the same modifier as you give for the shear walls. But yeah, I agree that there is lack of clarity when it comes to code for the stiffness modifier for basement walls, especially when it gets connected with the shear walls. Okay. Salik Rambo is saying this is regarding stability bracing. Can you share basics regarding how we calculate fly brace requirements as code requires us to check? Okay, so you said this is not the fly brace. Then what is the fly brace? Then I'm not sure what is the fly brace. Oh, you mean in the IS 1816 said the bracing that it gives us? Do you mean that? If you could please elaborate the meaning of fly brace. I think I understood it incorrectly. So if you could please tell me. Abhishek Mishra is saying in your RCC residential course, what do we learn? You could go to the project design course tab on our website. There you will get to see the course contents, and you will also get to watch the introductory session and the first session. It will highlight and explain you what all things we are going to cover in the course. And it is an actual residential bungalow project that we have done taken in the course and designed it. Engineer's advice is asking which software is used for tensile membrane structures. I don't know. I'm not sure. Okay. So I think we have reached to the end of the questions that were asked. So we have taken questions from the Google form. We have also taken questions from email. We have taken questions from the YouTube comments. And I guess these are the questions that we had. So if there is no other question, we can close today's session. Okay, then. So that is it, I guess, for today. Thank you. And I hope for those who had asked questions, they were able to get their answers. If not, maybe you can provide some sketch for better explanation of your question, or you can email your queries to. I am putting this email in the comments over here. Yeah. Yeah, so put your queries over here, contact at auxen.in. If you want to give some sketches, you could give sketches as well. Or I guess you also have the link where you can submit your queries. So on this Google form link, you could submit your queries and we would take up your questions. Maybe if not answered today, maybe in the next session we can take them up. So next session will again be on the next Saturday. So I'll just, yeah. In the comments, I have also shared the link for the Google form. You can take it from the, click on the comment on this link and you will be redirected to the Google form where you can put in your queries. Okay. Mr. Salik is saying for a PV structure I am reviewing, they perform response spectrum analysis for the steel structure. However, they are not reaching 90% mass participation even after taking 25 modes. I don't think the higher mass, I mean, even if 90% of mass gets participated, I would be happy enough because uh, because this is a structure where higher modes may not lead to any conclusive or I mean they will not lead to any important outcome as such. Okay, so maybe some small portion vibrating here and there. Otherwise, in the initial modes, if you are getting 90% mass participation or even 70-80% mass participation is good enough, I guess. Anyway, you are going to do the Bezier scaling, so you are going to amplify the shear force anyway. So I will not be very worried about a PEB structure, assuming it's only a PEB shed-like structure. Even if you are getting close to 90%, even not 90, I will not be very worried. Okay, because I don't see anything meaningful coming out of the higher modes. Yes. So then we stop for today. Thank you, and we'll see you next weekend now. So you could continue putting your queries. Acha, yes, question. Okay, Salik is saying for the flank bracing, you showed for bracing the bottom requires to be checked for strength and stiffness. Strength part is easy, however, how to check stiffness? You go to IS 18168. If you go to IS 18168, they have given provisions for bracings, different types of bracings. They have given provisions and they have given some formulae to calculate the stiffness and strength both. Strength is easy because directly 2.5% of axial load, that type of calculations you could do. But for stiffness, you go to IS 18168, there are formula given over there. Okay, to check the stiffness of such bracings. Okay, yes. All right then. So thank you. This is all we have for this week. We'll see you in the next session, episode 3 of Ask AuxEn Anything, next Saturday on 23rd of November. Till then, bye bye.